Okay, we are continuing with series of videos on cuda, and this video is going to be the fifth video where the pointers example is explained. Actually, this is a prerequisite for cuda programmers. So I thought I should do a video on pointers before we start doing any cuda programming. So now, as you can see on the screen, this is a basic concepts of pointers, and which everyone should know before starting any cuda program. What is cuda? Cuda is a parallel programming computing platform, and it's an API model that's developed by NVIDIA for NVIDIA GPUs. Now, many of the videos are taken from tutorial points. You can also see that. And what's a pointer? And we are going into the very basics of pointers in any general C language. It's a variable that stores a memory address as its value. So as you can see on the screen, the moment I say A is equal to 5, that means A is the name given to the placeholder where number 5 is kept, and the place where the address where this data is stored is ampersand A, that is address of that. A is the variable name and ampersand A is address. And you can always now refer integer star pointer A is the address of A, is equal to A. That means what happens? Suppose A is having a value 5 would go into a memory location which is having a name A, and that is pointed by an address PTR A. So PTR A is nothing but the address of A. Now this is becoming more clearer in real sense actually. So it is not necessary you can store integer, you can store character, string, etc. in variables. So let's say the variable is var and is having number 10. You can see that there is an address which is nothing but a long number. This is a memory address in hexadecimal which is pointing towards that. You can see that. So the point PTR contains the address, this address inside. Now, typical cuda program flow is all about memory pointers and memory locations and memory based data allocation and also memory copy. So a typical system looks like that. You are always sitting in the CPU and programming. You are writing the cuda program from here and you want it to run on a GPU. The first step would be load the data into CPU memory. That means suppose I want to store a data A, variable A. So you first write the program inside the CPU and load the data here. A is equal to 5 or something. And from here the second step would be copy the data from CPU into the GPU memory. And this memory is very different from this memory space. Totally two different far memory. This is a far memory. So there is a technique, there is a programming technique to copy the data from this memory to this memory. That's the second step. And third step is you execute the program. That means the GPU, that is a GPU kernel is executed sitting from, see you are sitting here but you are executing that kernel remotely here inside the GPUs. And fourth step is actually the whatever results you have got. Let's say you have copied A to here and you are done some A plus B something and you get a C here and C is returned here to the fourth step. And fifth step will be just print the results on the CPU. So these are the different steps. But you see actually in all these steps actually the pointers are being used because pointer is pointing to an address, and this is all memory game actually. There is a memory here, there is a memory here, and you are doing a lot of manipulation with memory. So that is why pointer concept is very important. See, look at the typical program actually, where you have a number in the CPU, number is equal to 0. You would like to take it to the GPU and just print that value, let's say. So the steps involved, actually you have to use a library called cuda underscore runtime.h. So now you have to use pointers, because you are going to play with functions like memory allocation is done through cuda malloc, and cuda malloc means you are going to allocate memory in the distant far off memory location, that is in the device, that's in the GPU. Simple malloc means it will create memory, it will allocate memory in the local CPU. But now when I say cuda, that means in the remote memory, that is in the GPU. And cuda mem copy means it will copy the memory content from GPU to the CPU. So you can see that actually right now number is equal to 0. You have created a pointer D number, that means D means the pointer, okay, to this particular number, the address of the location. So after that what I did, actually I allocated a memory. Jitna memory, whatever memory it takes actually, memory space required for storing a number 0, that is nothing but it's an integer. You know that it may be taking 4 bytes. That means the starting address of that. That is what is the integers are the starting PTR. This is PTR. This is a PTR to that number. That is D underscore number. So using cuda alloc, actually you are passing that address, the data of which is stored inside this. Actually, the size of that much memory is allocated in the device using this particular line. And you can see, you might think I could give simply integer star here, but this old star we have given because star is basically pointer to pointer, because it looks like you will realize why star is required. It is in a distant far off memory, which is not the local memory. So it is only star is for the local memory, star is for the device memory pointer, that is. So when you do this, actually it is creating a space for storing the number is equal to 0 in the distant memory location. After that, what you do, you are copying memory copy. So memory copy from host device, that means host device में आप copy कर रहे हो data को. And after that, from when you launch a kernel, actually change to 42 is a function which is being executed in the GPU, where what you are doing is actually you are sending a number to the GPU, and the number value is being changed in the GPU and returned. So you send 0 when it inside it's like you are sending a child to the school, and the school, his name has been changed and his age has been changed and sent back, something like that. So this function is going to do that, actually change number value to 42, 1,1. This is how you send it. This is the syntax for that. And D underscore number is a pointer, remember that. So this is the function which you use, cuda malloc, the pointer. This is a pointer to pointer because it is sitting in the device, the size. Now once after you execute this function, change the number to 42, you have to bring it back also. So for doing that, you have to copy the memory content from the GPU to the CPU. So this is the syntax for that: memory copy device to host. Earlier we did host to device, now device to host. And after that, you are simply printing the STD, means standard output, that is in the CPU only. In the screen you are printing the number after change. And whatever memory locations we are using, just free that actually, otherwise it can give memory fault errors. So cuda free is required for that. Segmentation fault etc. will happen if you don't use this. So the same thing we have explained, actually now a little more detail. The cuda malloc is basically allocating memory in the device far off place. Memory copy you used, memory cuda malloc used, etc. etc. Memory copy used. These are the functions which we explained earlier. You can stop the video and see this later. And now the output of the program. Now let's say you have created this program under cuda malloc.cu, and this program has been written there, and you nvcc cuda malloc.cu, execute it, a dot out, it prints out. You send the number 0, you are getting 42 in return. And we are going to see a demonstration of this actually now, how we are going to do that actually. So so we are connecting into a GPU system which is sitting far off from here, and you can see that I am connecting into that GPU. So it is connected. Now you will be seeing the screen of the GPU. That's a Jetson Nano GPU installed with 18.04 version of Ubuntu, and we are connecting through the AnyDesk into that machine. It is, you can see the screen is here. It is slightly slow because of the network. See, I am just putting 10.1.10.163 is the static IP of that particular Jetson Nano device. That is the GPU. Now you just logged into the system, and as I said before, we are executing, and we can see the nano of that particular nano editor. Nano editor, you can open that program. Now see, this program is opened. You can see this is the program, exactly the same thing what we explained earlier. We had a number 0 and we are copying into the device, then changed using the kernel. Kernel is launched, this got executed, number got changed to 42, brought it back and freed the memory. Now we will compile this using nvcc. Then we are now running the a.out. How many times it should print is pretty clear. It is only one time it will print, because 1,1, one block and one thread, and number is changed to 42 from 0. Now that's all about this particular video.